Alright, in this video I'm going to do an example of solving a rational inequality, and basically the procedure to me when solving rational inequalities, and again, a rational inequality is just a fraction that involves polynomials. The first thing I want to do, and this can often be a little bit of the tedious step as well, it's all pretty tedious honestly, is I want to write the left side as a single fraction. So that's all I'm saying, or make one side a fraction. So p of x over q of x, this is a polynomial, this is a polynomial. Okay, we want that to be less than 0, or it can be greater than 0, less than or equal to, or greater than or equal to. All I'm trying to say, make one side a fraction, make the other side 0, whatever the type of inequality is, I mean that's fine. At this point what we do, we set the numerator equal to 0 and we solve that. We set the denominator equal to 0 and we solve that. We take all of those numbers and put them on a number line, and then we have to test points, very much just like when we do a quadratic inequality. Exact same ideas, basically. So let's start off here. We've got 2x minus 4 over 6x plus 18 less than or equal to 0. So this one's nice because we've got, we set up everything pretty conveniently. We've already got one side equal to 0. So step 1 on my little checklist is already complete. So now what we have to do is we have to solve the two equations. 2x minus 4 equals 0. We also have to solve 6x plus 18 equals 0. And fortunately, these two equations are pretty manageable. So I can add 4 to both sides and get 2x equals positive 4. Divide both sides by 2, and that'll give me x equals positive 2 is one of my solutions. The other solution, I'll subtract 18, so that'll give me negative 18 on the right. We still have our 6x on the left. If we divide both sides by 6, we'll simply get x equals negative 3 on the right side. Okay, so now we've done a little step 2, and what I'm going to do now is simply test, I'm going to put these numbers on my number line, and then I'm going to test these numbers. So first off, notice if you plug negative 3 in. If you plug negative 3 into this rational inequality, especially if you plug it into this rational expression on the left, we're going to get 0 in the denominator. And if you get 0 in the denominator of the fraction, that's undefined. It's not a number. So that what it says is, it says negative 3 simply cannot be a solution. So I'm going to put a big open circle there to indicate it doesn't work. Okay, what about positive 2? Notice if we plug positive 2 into the rational expression on the left, we'll get 0 in the numerator. We won't get 0 in the denominator. 0 divided by some number is 0, and hey, 0 is less than or equal to 0, so positive 2 will work. Okay, unfortunately we're not done yet. Now we have to take a number from each interval and again test it in our inequality. Okay, so again we have the inequality 2x minus 4 over 6x plus 18 less than or equal to 0. Well, let's see, some number smaller than negative 3. Maybe I'll test x equals negative 4. So if I plug negative 4 into my inequality, let's see, we'll get 2 times negative 4 minus 4. And then in the denominator, we'll have 6 times negative 4 plus 18. And again, I'm asking myself, is that less than or equal to 0? Okay, so 2 times negative 4 is negative 8. Negative 8 minus 4 is going to be negative 12. In the denominator, we have 6 times negative 4, which is negative 24, plus 18. Well, negative 12, he just stays on top. Negative 24 plus 18, that's going to give me, I believe, how about negative 6? Well, we've got a negative over a negative, which is a positive, and we can actually simplify that to 2 pretty easily. So on the left side it says we're getting 2, and again, is 2 less than or equal to 0? Well, definitely not, so that means x equals negative 4 is not a solution, and that means no number smaller than negative 3 will satisfy my inequality. Maybe the next number I'll use, I'll test x equals 0 since that falls in the middle, and again that makes the arithmetic nice and easy. So if we test x equals 0, notice 2 times 0 is just 0, so we'll be left with negative 4 in the numerator. In the denominator, we'll get 6 times 0, which is 0, so we'll be left with 18. And again, is that less than or equal to 0? Well, we have a negative over a positive. That's definitely a negative number. Is a negative number less than or equal to 0? You bet. So what that says is, it implies that any number then between negative 3 and 2 will be a solution to our rational inequality. And now we can just test any number bigger than 2. Maybe I'll test, I don't know, how about x equals 3? So if I plug that into my inequality, we'll get 2 times 3 minus 4. And again, I'm thinking, 6 times 3 plus 18. Again, I'm asking myself, is that less than or equal to 0? Well, notice in the numerator, 2 times 3 is 6. 6 minus 4 is 2. In the denominator, I almost don't even do the arithmetic. I clearly see it's going to be something positive, but okay, so 6 times 3 is 18 plus 18 is 36. Is that less than or equal to 0? Well, again, the left side's positive. A positive number is never less than or equal to 0, so that means 3 didn't work. So what that means is the only solution to our original inequality are the numbers between negative 3 and 2. So we can write that in interval notation by using parentheses around our negative 3. We go up to 2 and also include it, so we'll put some brackets around it to indicate that.